First part of this video, and it's kind of confusing because I had to call it problem 1A part 1, so this is problem 1A part 2. I'm gonna try and see if we did everything correctly here, and if our solution works in MATLAB. So let's go over to MATLAB and let's do this. The first thing I'm gonna do is I'm gonna clear all old variables just in case. You do that with the clear all command. Then what I want to do is I want to define the transformed versions of x and y. You could put in the Laplace in. Actually, let's put the Laplace in just to do it all in MATLAB. So defining the system. So we're going to have to declare some variable, declaring some variables, which you do with the sims command. And it's going to be our x of t and our y of t. As we see, because we have dx dt, which means that the x changes with respect to time, and dy dt, y changes with respect to time. We assume that's the only variable that there is. That's the only independent variable. So now I'm going to say that the derivative of x with respect to t is going to be equal to minus x plus y. And that the derivative of y with respect to t is going to be equal to 2 times x. And we want to apply the Laplace to this. So are we able to, let's make this an equation with double equal sign and apply the Laplace. I don't know if it'll take it. We'll try Laplace. And so this is going to be equation 1 and this is going to be equation 2. So we press Control Enter. It did take it, and this stays this way. Well, let's see this if this makes sense. X of 0. Here, what I'm going to do is I'm just going to take this out and see if it makes it a little bit more readable. No, it doesn't change much. But we know that this is going to be x, the big X of s, because we replaced the t with the s. This is going to be the big Y. This is going to be minus y of 0. And then here we're going to have 2 times the big X, which is what we got. Here we have that big X and the y. So it seems like that part can be checked. Now let's define our transformation. So let's just say that we had s times that big X minus x of 0 here, which is just 0, they told us, so we're not going to write anything. That has to be equal to minus that big X right here plus the big Y. That's our first equation. Now for our second equation, so this we don't want it anymore. We just wanted to check if it was right. For our second equation, we're going to write s times the big Y minus 1, that was our initial condition for y of 0. And that's going to be equal to 2 times big X of s, which is this one right here, 2 times big X. And now these are our two equations. And we're going to put a comma. And here inside the brackets, we'll put that we want to solve for x and y. And so we want to redefine x and y with that. And then we want to put this as the argument of the solve function. We also want to declare what x and y are, and s. And now we press Control Enter. With Control Enter, we get these two expressions. Now remember what we had in our paper. In our paper, we had s plus 1 over s squared plus s minus 2. They just multiplied the s times the s plus 1. And so the denominator is the same, so we so far we have the same thing we did by hand. So now we can applying the partial fractions. So my x is going to be part frac of x. So I just want to rewrite it in a different way. And my y is going to be my part frac of y. I press Control Enter one more time here. It has to redo the whole thing. And then we get what we got before. We get 2/3 s minus 1 plus 1/3 times 1 over s plus 2, which is for our y, and 1/3 s minus 1 and minus 1/3 s plus 2 for our x. Then what we do is applying the inverse Laplace, which is called Laplace in MATLAB. We do it for the x and we do it for the y. So what we get is going to be a small x of t and a y of t. Press Control Enter, and let's see what we get out of this. Well, here we get e to the t over 3 for x, which is what we got, minus 1/3 e to the negative 2t. Okay, that checks out. And this one is e to the negative 2t over 3 plus 2/3 e to the t. That's what we got. Now, if we wanted to be even more sure, we can check the solutions by plugging them back in and see if we get an identity. So remember how we had this? Well, let's see if we get an identity now that we know what x is. And then let's see if we get an identity here now that we know that y is. And we're going to get a different output here because now the x and y is defined. See? It knows what it is. So it can actually take the derivative of it. So we can take the derivative and press Control Enter to see if we get the same thing on the left and on the right, which we do in both cases. So we know that these are indeed solutions. And so this is how you check in MATLAB. I'll see you for the next problem. Have a good one.